This screencast is going to walk you through some examples of using the distributive property to create equivalent expressions. So if you remember with the distributive property, we are looking at some of the examples like what's on the screen, where you are sharing a common number or a number that's out in front of the parentheses with whatever is within the group or the parentheses. So we're going to go ahead and take a look at both numerical and algebraic expressions using the distributive property. If you take a look at the examples on the screen, these examples are not on your worksheet yet. These are just going to be examples that we kind of go over before working through the examples that are on your graphic organizer. So if you take a look at the first example, this is just a numerical expression because it just contains numbers and operation symbols. If you take a look at the numbers and operation symbols, you're again going to notice that you have a 3 out in front. Remember, the number that's in front of the parentheses is the number that you are always sharing within the parentheses. So again, we know that anytime we see a number next to parentheses, it means multiplication. So we're going to multiply 3 times 2. And then we're going to share the 3 with a 5, which would look like 3 times 5. And then to tie those two expressions together, we're going to use addition. From there, we're going to then solve. So we're going to do 3 times 2 is 6, 3 times 5 is 15, and then 6 plus 15 gets you to an answer of 21. So again, this expression would be equivalent to this expression. We're sharing the 3, which is the number out in front, with the numbers that are inside the parentheses. Taking a look at example 2, example 2 is now an algebraic expression as it has a variable, the letter G. So that is how we know that it's a different expression than a numerical expression because of the variable. Again, the number out in front is a 4, so that would be the number that we are sharing. Again, we know that if we have a number next to parentheses, that means multiplication. So if we share, we're going to do 4, share the 4 with the 3G. So we're going to create the expression 4 times 3G, and then we're going to share the 4 with the 2. Always important to remember to share the number in front with everything inside the parentheses, not just the first number, not just the second number, but both numbers. This time around, our connection or our symbol that we're using to connect both of the expressions together is a subtraction symbol. We can continue to simplify. We can't officially solve this expression because of the fact that we have a variable and we don't know what that variable or letter is equal to. But we can do 4 times 3G. Remember, you just take the two numbers, the whole numbers, and multiply them together. So 4 times 3 is 12, and we bring the G along for the ride. We can evaluate or solve 4 times 2 because they are both whole numbers, and 4 times 2 is 8. Finally, we connect those two expressions or parts of the expression with our subtraction sign, and we get a simplified algebraic expression of 12G minus 8. So the example 4 times 3G minus 2 is equivalent to 12G minus 8. Now we're going to take a look at your examples that are on the graphic organizer in front of you. So if you take a look at example 1, this example is a very simple example using the distributive property where you have your common number out in front and you have two terms or two pieces inside your parentheses. So again, which number are we sharing? We're sharing the 4, and we're sharing the 4 with the y. So we know that we're getting 4 times y. We're also sharing the 4 with the 9 to get 4 times 9. We're connecting these two expressions with an addition sign, and then we can simplify this down. 4 times y is 4y. 4 times 9 is 36. And then we're going to put our addition sign in between. We cannot combine this anymore because we do not know what y is equal to. So since we don't know what y is equal to, we can't simplify this anymore, so this would be our equivalent expression to 4 times y plus 9 is equivalent to 4y plus 36. You'll notice that our ending part right here is kind of what it looks like we're starting with. And again, make sure you're writing down these examples so that you can refer back to them as you move on to the practice part. Example 2 is kind of the finished product of the distributive property. So if you think about our last example that we did, 2. So in example 2, we have 30a minus 6x. So we're kind of working backwards in this example. We're starting with the end result of the distributive property, and we're kind of doing the reverse order. When we have 30 minus 6, this should look somewhat familiar. We did this before with just numerical expressions, where we had to figure out what the greatest common factor between the two numbers were, and then that was the number that we placed out in front of our parentheses. So we're going to do the same thing this time around. We're going to figure out what is the greatest common factor between 30 and 6, and then we're going to put that out in front and then fill in what's left in the middle. So the first thing that we need to do is list our 12s method for both the number 30 and the number 6. So if you take a look, I did go through and make my list. So if I go ahead and compare my lists to each other, I can see that I have a 1 in common, a 2 in common, a 3 in common, and a 6 in common. So that would tell me that 6 would be my greatest common factor. So that's what I'm going to factor out or put in the front of my parentheses. Because I'm putting that in the front of my parentheses, that means that I have to take that out of 30 and 6. So I'm going to divide 30 by 6, and I'm going to divide 6 by 6. So 30 divided by 6 is 5, and 6 divided by 6 is 1. Now before, this would be our final answer, our 6 times 5 minus 1. But in this example, we have variables. We have an a and we have an x. So like with our other examples, because we don't know what the a and the x stand for, we have to bring those along for the ride. So what that's going to look like is we're just going to keep the variable attached to our number. So our final answer would look like 6 times 5a minus 1x. So our final answer for this example of an equivalent expression would be 6 times parenthesis 5a minus 1x. Our next example is looking at finding equivalent expressions and selecting all that apply. Key item when selecting all that apply is that there's probably going to be more than one answer. So you probably shouldn't just be checking one answer. There's probably more than one. The first thing that I would take a look at is our original expression, 3 times parentheses c minus 5. As we talked about a little bit before, you could also see the expression written with the 3 behind the parentheses. This is still showing that you're multiplying. It's just not a common way to write this type of expression. However, if you jump down to your choices, you will see that letter A shows c minus 5 in parentheses with the 3 behind it. So we know that sometimes they're going to have us checking to make sure that we're understanding that you can kind of reverse or change the order. The next piece is going to be to use what we know about the distributive property to now rewrite the equivalent expression. So again, if we take a look at the 3 times c minus 5, this is where we want to go ahead and share the 3 with whatever is inside our parentheses. So we're going to share the 3 with the c, and that's going to become 3 times c. And we're going to share the 3 with the 5, which will become 3 times 5. Connecting those with our subtraction sign, and then from there we can simplify or kind of condense, put together our two expressions. So 3 times c becomes 3c, 3 times 5 is 15, connect with our subtraction symbol, and here is another equivalent expression. So if we go back to our list, we want to look and see, do we see this 3c minus 15? Yes, that would be letter D. The reason why letter C is not going to work is because notice what's in the parentheses is not what we started with. So this would not be equivalent. Same thing with B. Notice that with B, they only shared the 3 with the C and not with the 5. So this would also not be equivalent. So A and D would be our equivalent expressions for example 3. In example 4, again, very similar to example 3. Which of the following is equivalent to the expression 3 times 2y plus 4? Select all that apply. So if we take a look, we have 3 times 2y plus 4. So right away I'm going to go through my list and I'm going to say, okay, none of these right away are matching what I already see. So that tells me that I have to go through the process of finding an equivalent expression, which means I have to share the 3 with whatever is inside my parentheses. So I'm going to share the 3 with the 2y, which will become 3 times 2y, and I'm going to share the 3 with the 4, which would become 3 times 4. Connecting this with my addition sign, and then simplifying. So remember, we can share or we can combine the 3 times 2y. We multiply 3 times 2, which is 6, and we bring the y along for the ride because we don't know what y is equivalent to yet. Same thing with 3 times 4. These are considered like terms because they're both whole numbers. 3 times 4 is 12, so another equivalent expression will be 6y plus 12. So if I jump back up to my list of A, B, and C, I can see that the letter B would be true. So I'm going to go ahead and circle that or check that, and I'm going to get rid of C because, again, they shared the 6y, but they did not do the same thing with the 3 to the 4, so they forgot about the 12. The last one is letter A, so I have to make sure that I carefully think through this. If I look at my expression here, I have 3y plus 12 plus 3y. If I look at the terms or the parts of the expression, I see that I have two numbers that look alike. I have 3y plus 3y. Because both of these numbers or terms have a y attached, I can combine those together. So what I would do is I would add 3 plus 3, which would get me to 6, and I'd bring the y along for the ride. What I have left is my plus 12, so I have 6y plus 12. 6y plus 12 is equivalent to what we found in our other example of 6y plus 12, so that tells me that letter A would also be an answer. So that means that A and B would be my answer choices for example 4. Our final example, example 5, is looking to write an equivalent expression selecting all that apply. So again, that word all. So I have 2d plus 14. So again, important piece to this is looking right away, I don't see anything that looks similar to just 2d plus 14 written a different way. So I need to go through and look at my whole numbers, and I need to go and do the reverse distributive property. And the reason why I have to do the reverse distributive property is because this is my final answer, and I need to work backwards to figure out what my original expression looked like. So going back and looking at the whole numbers of 2 and 14, those are the numbers that I'm going to use for my 12s method. So I'm going to go ahead and do the 12s method for 2 and 14. So if you take a look at my list, you can see that my common factors are 1 and 2, making 2 my greatest common factor. So 2 is going to be the number that comes out in front. I'm then going to divide each of these numbers by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. And then again, because there is a letter or a variable attached to the 2, I'm going to go ahead and add that back in. So my final expression would look like 2 times 1d plus 7. Now, you may go back and look at your answer choices and say, okay, well, I don't see a 1d. 1D or 1 times D is the same thing as D. So think about it, if I have 1D, that would just look like the letter D. So I'm going to go ahead and think about that and say, okay, I'm looking for anything that looks like 2 times D plus 7 with the D plus 7 in parentheses. So what I just boxed in red. So I'm going to go through my list. Letter A does not look like that. Letter B does look like that. So I'm going to go ahead and circle letter B. Letter C does not look like that. Letter D has the D plus 7 and the 2 behind it. Okay, so they're just trying to mess with me again. They changed the order. So B and D would be my answers to example 5. So again, remembering that when you're working with the distributive property, you have to think about sharing that number that's in front with whatever is inside your parentheses to create an equivalent expression. Whether you're working with a numerical expression or an algebraic expression, you're still using that same format of finding an equivalent expression using the distributive property. Remember to always share with each part and make sure that you're combining or simplifying your terms so that you are looking at its simplest form. So in this case, I don't know what G is, so my simplest form would be 4G plus 4. Use these examples to kind of help you work through your practice in the next part of this lesson.